Hi everybody, this is Pre-Calculus, week 19, and this video covers parent functions and absolute value functions. Alright, so what is a parent function? A parent function is a simplified function, like the most simple version of a function in a family of functions that shows us the graph of that type of function. So the first one we're pretty familiar with. This is the constant parent function, so that's f of x equals a. And a could be any number. So for example, this one would be f of x equals 4, right? So no matter what x is, f of x is always 4. And remember that f of x can be replaced with y, right? So we've seen this before. This is just a horizontal line function. This is y equals, right? So if we had, no matter what x is, no matter what y is, x always equals 4, right? So that would actually be x equals 4. Right, so we've done this. It's just the equation of a straight line, and a function and an equation are very, very similar there. We just remember that when we have f of x, we can replace that with y. So f of x equals 4. If we wanted to change this, translate this function, so translating means changing the function to move this graph. If we had f of x equals, let's say we wanted the graph to be at -3, we could move it right there, and it would be f of x equals -3. So whatever number we replace this a with moves the graph up or down. Right, and negative numbers are going to go below your origin line, your 0 line, x equals 0, and your positive numbers are going to go up, right? So this is the same as saying y equals a, right? Whatever y equals makes a horizontal line. And remember, when we made vertical lines, that would be x equals. No matter what x is, y is always going to be equal to whatever that is. But remember that a vertical line is not a function, just a horizontal line is a function. All right, the next parent function that we'll look at is a linear function, and this is the same thing as a linear equation. So when we write the parent function for a linear function, it is f of x equals x, right? So that we could make a little table and have our x and our y values, and remember y is f of x, same thing. Okay, so if x was 0, what's y going to be? Well, if f of x equals x, whatever x is equals x, so if that's 0, then that's 0. So that means y is 0, and that's right there in the center. If we did 1, then we're going to get 1. So 1, 1 would be here. 2 would be 2. Get that right there. 3 would be 3. That would be that point there. Same thing with like -4 would be -4. That would be right there. Okay. Now we can translate that function, move it around using the formula of a line, which is y equals mx plus b, right? So if we change this b value, that's our y-intercept, that's going to move our function. It's going to shift it up or down, right? So if we said f of x equals x plus 2, right? If we make our x and y chart right here, if x is 0, y is going to be, if we had 0 plus 2, we're going to get 3. So that makes that be 3. So if we were to plot that point, we would have 0 on our x, and our y would be 2. Okay, what about if we have 2? Well, 2 plus 2 would be 4. So we would go 2, 4, that'd be right there. If we did -2, negative 2 plus 2 would be 0. So that would be right there. So that just shifted this same line, shifted it up 2 points. Just moved it up 2. Right? If we did a negative number, so let's say that we did f of x equals x minus 4, right? If we had our x and our y chart right here, and remember y is just f of x, right? So if we said 0, 0 minus 4 would be negative 4, so we would be at y equals 0, x equals 0, y equals negative 4, that'd be down here. And then if we did 2, we would get 2 minus 4 equals negative 2. 2, negative 2 is right there. And then if we did negative 2, we will get negative 2 minus 4 equals negative 6. So that would be here, and that's just going to shift our line down 4, right? So we've already done this when we did linear equations. Linear functions are the same thing. The other part of it is our m, which is our slope, and that's going to change the slantiness of our line. So right there. Okay, so if we said f of x equals 2x, right? If we did our little x and y chart, that's really f of x is y. Let's say we had 0. 2 times 0 would be 0, so that's still going to be in the center. 1. 2 times 1 would be 2, so we're going to be at x is 1, y is 2. Negative 1. Negative 1 times 2 would be negative 2. So we will be here. What if we said 4? 2 times 4 would be 8. So for there, we're going to be all the way up at 8. See how we get a line with a smaller slope. Right? Our slope changed. It just slanted it up a little. Now, if we wanted to slant it the other way, we would have to use a fractional m value. So if we said f of x equals 1/2 x, right, we could have 0, and that would be 0, so still in the center. 2, half of 2 would be 1, so if x was 2, we would have 1, that'd be right there. 4, half of 4 is 2, that would be right there. See how that would make one that was more sloped, right? So it's going to be at a 45 if our slope is 1. As though it gets higher numbers, it's going to go that way. So above 1, m is greater than 1. Okay. As we go this way, m is less than 1. Right. So these are going to be all your fractions in here. As it approaches 0, the slope is going to get more in that direction. Now, if you have a negative slope, remember that just means that we have a downhill slope. So it flips it the other way. So let's do one with a negative slope. F of x equals negative 2x. So 0 would still be 0. Let's try 2. Negative 2 times 2, right, would be negative 4. So if we were 2, then we'd be at negative 4 down there. 4. Negative 2 times 4 would be negative 8. So that would be down there. Let's say we did negative 3. Let's do one easier. Let's do negative 2. Negative 2 times negative 2 would be positive 4. So it would be up here, right? And it just flipped our line to make it the slant go in the other direction. Alright, so you could put all those together and have multiple translations at the same time. So let's say that we had f of x equals negative 2x plus 3. This right here tells us where our y-intercept is, right? So that's right here. And then this one tells us our slope is negative 2. And remember, that's rise over run, so negative 2 over 1. So what we did was we moved our graph up 2, and then we're changing the slope to 2 over 1. Negative 2 over 1, that means go down 2 over 1. So that'd be right there. Down 2 over 1, that would be right there. Down 2 over 1, that would be right there. And we can plot our line. I didn't do that very well. Let's see. Try that again. Oh, that was terrible. Anyway, so you guys can see. And we have done this before. That's just the parent function for a linear equation. Alright, so now we're going to go over a new one, which is called a absolute value equation. And the parent function for an absolute value equation looks like that. It's f of x equals the absolute value of x. Alright, so if we made an x and a y chart for that, and remember, y is just f of x. If we put 1 in here, the absolute value of 1 is 1. So we'd be at 1, 1. If we put 0 in there, the absolute value of 0 is 0. If we put negative 1 in there, the absolute value of negative 1 is still just 1. So that puts us here. So this is going to be a V shape. Alright, so now we're going to learn how to do some translations on that. Alright, so we're going to start by graphing some absolute value functions, and we're going to learn what that does. So this one has us graph. This is the parent function. Alright, and we're supposed to be graphing y equals x. So if we make a chart for that, our x and y, we're going to have, let's say x is 0, y is going to be 0. X is 1, y is going to be 1. X is 2, y is going to be 2. X is negative 1, y is still going to be positive 1, right? Because it's the absolute value of x. That means we can't have any negatives. So that goes there. If x is negative 2, y is going to be positive 2. So negative 2, positive 2. And we get our parent function, which is a V shape on our graph. Having trouble drawing straight lines here. That was terrible. Erase it one more time. Try one more time. There we go. That's a little better. Okay, so now we're going to try this next one. This is y equals x, the absolute value of x minus 2. Alright, so we're going to make our x and our y chart right here. Alright, so if x was 0, right, we would have 0 minus 2, which would be negative 2, and the absolute value of negative 2 would be positive 2. Y is going to be 2. So x 0, y 2. It's going to go right there. Okay, if x is 1, we would have 1 minus 2, which would be negative 1. Absolute value of negative 1 is positive 1. So we're going to have 1, 1, which would be right there. All right, if x is 2, 2 minus 2 is 0. Absolute value of 0 is 0. That's going to go there. We could do a couple more. What if we have 4? 4 minus 2 is 2. If we go to 4, we're going to be at 2. We still have our V shape, but it's just been shifted two units to the left, to the right. Okay, so we're looking for relationships in here between these numbers and what happens to our graph. All right, so this graph moved 2 units to the right, and I would say it has something to do with this 2 right here. All right, let's do another one. This one has plus 4. So here's our X and our Y chart right here. All right, so let's say that X is 0. 0 plus 4 would be 4. So we're going to have 0 plus 4 is 4 right there. Let's try 2. 2 plus 4 is going to be 6. That's up too high. That's not on my graph, so I'm not going to do that one. Let's try some negative numbers. Let's try negative 2 plus 4 would be 2. So we've got negative 2, then we've got 2. So if X is negative 2, Y is 2, that'd be right there. All right, let's try negative 4. Negative 4, positive 4 would be 0. So that's there. Let's try negative 5, just to figure out where that goes. Negative 5 plus 4 would be negative 1, and then we take the negative off because it's inside the absolute value, so that would just be 1. That would be right there. So here is the graph to that one. And it has just been shifted this way, right? It's that same V shape. We just moved it to the left. Four units. All right, so what tells us to do that? Inside the absolute value sign, this 4 right here made us move left 4 units. This negative 2 made us move right 2 units. All right, so if we look at this basic formula for this, we have y equals a times x minus k, h plus k. This minus h right here is what we're talking about. This is going to shift left or right. Now, did you notice that when it was positive, we went left, and it was negative, we went right? That's because this says minus h, right? So we have to change the sign. Right, so minus negative 2 would be positive 2, meaning we would go towards the right 2 units. Minus 4 would be negative 4, meaning we go to the left 2 units. All right, let's try a couple more. This one, we're going to make an X and Y chart right here. Okay, so if it's 0, 0 plus 3 would be 3. 0, x is 0, y is 3. If it was 2, 2 plus 3 would be 5. So we've got X is 1, 2. Y will be 5. That's all the way up there. Let's try some negatives. Negative 2. So if we had negative 2, that would just be 2 again, right? Because it's the absolute value of negative 2, which is 2. 2 plus 3 is 5. So if we are at negative 2, it's also going to be 5. Let's try negative 1. That would actually just be 1. 1 and 3 is 4. So that's going to be here. Positive 1. 1 and 3 is 4. That's going to be here. See how they're mirroring each other? So this shifted us up. From our parent function. Our parent function would be there, and we just went up 3 units. Okay, so this plus 3 outside of the absolute value sign, right? It's not in the absolute value sign, shifts us up 3 units. Okay, that part is the K right here. So let's change this to a different color. And now notice that our positive shift right here, our 3, is a positive number, and we went up. So we don't change the sign on that one. All right, let's try another one of those. X and our Y. This is the absolute value of X minus 2. So if X is 0, 0 minus 2 would be negative 2. If X was 1, 1 minus 2 would be negative 1. All right, let's plot those real quick. So we've got 0, negative 2. So X is 0, Y is negative 2. 1, negative 1. Right there. All right, let's try negative 1. Negative 1, the absolute value of negative 1 is 1. 1 minus 2 would be negative 1. So that would be here. 2 would be 2 minus 2 is 0. That's right there. Negative 2, same thing, because negative 2, the absolute value of negative 2 is just plain old 2. 2 minus 2 is 0. That would be there. So there's that one. And if we draw in our parent function, which is here, you'll see that it just shifted it down 2 units. This part right here shifts us down by 2. Okay? And that's what that says. Our K, whatever plus or minus, is going to shift us. Positive is up, negative will be down. For the one inside the parentheses, our H, which is left, which is our left-right, left is going to be, see, it's the opposite. We have to change the sign. Left is usually negative. It's going to be positive, and right would be negative because we changed the sign inside there. All right, another one. What we got? All right, this one's a little bit different. This is our last part. This is kind of like the M on y equals mx plus b. So let's graph this one. Give it a different color here. Let's go with that color. Okay, so this one says y equals 2x. Okay, so here's our x and our y's. If x was 0, y is going to be 0. If x is 2, absolute value of 2 times 2 would be 4. If x is 2, y is 4 right there. If x was negative 2, absolute value of negative 2 is positive 4 right there. Negative 2 would be 2, and then that times 2 would be 4. So we're going to have a positive 4 on our negative 2. So right there, see how they mirror each other? Let's try 1. So the absolute value of 1 is 1. 1 times 2 is 2. Negative 1, absolute value of negative 1 is 1. 1 times 2 is 2. So if we have 1, that's going to be at 2. And then negative 1 is also at 2. Now, how did this change from our parent graph? If we put our parent graph on there, it goes like that. And this is just a shrink, right? It shrunk it down, right? So our slope changed, basically. If we look at the slope of both of these lines, this is up 1 over 1, right? Up 1 over 1, up 1 over 1. This is a slope of 1. And this basically, the other side is just a slope of negative 1. Right? If we look at our new slope that we have made, we are going up 2 over 1, up 2 over 1, right? So that is going to be a slope of 2. And this side would just be a slope of negative 2, right? Because it goes up 2, backwards 1, up 2, backwards 1, right? So this 2 right here told us that we need to change our slope from 1 over 1 to 2 over 2. Okay. That's called, actually that's not called a shrink, that's called a stretch, like we stretch the graph longer. Whoopsie. Sorry about that. Right. So that is our A value, whatever comes outside of that. And that's going to be shrink or stretch. That's going to shrink or stretch our graph. All right, let's try this one. This one is y equals negative 1/3 x. So here we go. We're going to have to pick some values that we could use with this easily. Okay, if that's 0, that's going to be 0. So there. So that, let's say 3. Okay, so if x is 3, that would be 3 over 1. Absolute value 3 over 1 is just 3 over 1. Those two would cancel, and we would get negative 1. Okay, so if we have x is 3, y is negative 1. Okay, let's try another one. Let's say negative 3. If we put negative 3 in here, that's really the same thing as positive 3. So we got negative 1/3 times 3 over 1. Same thing again, negative 1. Right? Because we know that this graph reflects itself. So that means that one goes there. All right, let's try 6. I'm not going to be able to do 6. It'll be way out here. So if we had 6 over 1, those two would cancel. We would have negative 2. So at negative 2, it's going to be way out here. Right, and this one would be a reflection of that way out there. So there's our graph. Now, two things have happened here. This one opens down, it's flipped the graph, and it has stretched the graph. So this is a stretch. That 1/3 is what stretched it. Okay, so fractions are going to stretch it. Whole numbers are going to, no, this has shrunk the graph. There we go. It shrunk it down, made it wider, right? So, oh, it's wider. The other one was skinnier. The other part is that this negative flips the graph. Okay, so our negative values open down. Opens down. Positive A opens up. All right, the shrink and the stretch, if it is A is greater than 1, it's going to get skinnier. A is less than 1, it's going to get wider. But it has to be more than 0. That's for your positive numbers. Positive and your negative numbers. Let's just make it say fraction. Okay. A is a whole number. Skinnier. A is a fraction. It's wider. There we go. All right. Here's another one for us to graph. This one, they have done everything to it. All right, so we're going to graph this one using a table of values. Then we're going to do the next one using the translations method. We're just going to look at each thing that's been done to this. All right, so here's our x and our y. All right, if x was 0, we would have 0 minus 2, which would be negative 2. Absolute value of negative 2 is 2, so all this is 2. 2 times 2 is 4. 4 minus 3 equals 1. So if x is 0, y is 1, right there. All right, let's try 1. Okay, so if x is 1, 1 minus 2 would be negative 1. Absolute value negative 1 is just 1. 1 times 2 is 2. 2 minus 3 is negative 1. So when x is 1, y is negative 1. Okay, let's try negative 1. Negative 1 minus 2 would be negative 3. Absolute value of negative 3 would be positive 3. 2 times 3 is 6. 6 minus 3 is 3. Positive 3. So if x is negative 1, y is going to be positive 3. 1, 2, 3. It's up there. Okay. All right, let's try 2. 2 minus 2 is 0. 0 times 2 is 0. 0 minus 3 is negative 3. So if x is 2, y is negative 3. Negative 2 will put us back up there somewhere. Let's try, whoopsie. Let's try 4. 4 minus 2 is 2. 2 times 2 is 4. 4 minus 3 is 1. There we go. So if x is 4, y is 1. Now we're getting somewhere. And there's our graph. Looks like we got a point right there. So if we put in x is 3, we should get negative 1. 3 minus 2 would be 1. 1 times 2 is 2. 2 minus 3 will be negative 1. All right, so there's that graph. So we've done all the things to it. let's describe those transformations that we did. So we took our parent function. Let's draw our parent function. We took our parent function right here. Oops, that wasn't very good. We took our parent function and we moved it. This tells us this is our h value, right? Y equals a x minus h plus k. That's an h. And just remember the h is for horizontal, so that's how far we move it back and forth. And this one we change the sign, right? So this is our left, right there. And we have to change the sign, so that would be plus 2, so that means right 2. So we moved it to the right 2. So we started there, and we moved it to the right 2. Yes, we went over 2. Okay. Then, this part, our K, is our up and down. That says we're moving it down 3. And we did move it down 1, 2, 3, right there. All right, and this is our shrink or stretch, right? And that 2 tells us that we made it be 2 over 1 instead of 1 over 1. So that means we shrunk it. It's up 2 over 1. So we changed it. We stretched it. We made it skinnier. Right. All right. So let's try that on this one. And we aren't going to make a table of values for this one. We are just going to try to work it out by figuring out what the transformations are. So on this one, we have, first of all, we've got this plus 4. That plus 4 is our h value. Think of that as being horizontal. And that would mean that we're going to go, let's see, we changed the sign to negative 4. That means we're going to go to the left 4. So we're, instead of here, we're going to be going 1, 2, 3, 4. It's somewhere over here, right? Then we did, this is our up, down, right? And this is telling us to go up 2. So we're going to go up 2. And that is our new vertex. The vertex is the point where your graph changes directions. Okay? Super easy to figure out what that vertex is. You change the sign of this one, that's your x value. You keep the sign of that one, that's your y. So it should be negative 4, 2 is our vertex. Negative 4, 2, right there. That's where it changes. All right, and then our slope here is going to be 3 over 1. That means we're going to be shrinking this down. So we're going to go up 3 over 1. So it's going to be like way over here. All right, so let's review this real quick. How does each variable affect the parent function of y equals x? So if a is less than 0, that means it's going to be negative, right? It's going to be a negative value. It's going to flip that upside down. It's going to flip our graph. That means it's going to open down. If a is more than 0, opens up. Right, so that would look like that. This one would look like that. If h is less than 0, right, so if h is negative, it's going to move it. Remember, we have to do the opposite of that. H is the one that is inside the absolute value sign right there. That's our horizontal. This is going to be our left, right. and we move it, we swap the sign, so negative h is going to be a positive move, so I move to the right. If h is, oh, whoops, I did that backwards. Yeah. I did this one backwards too. Okay, let me fix that real quick. Okay, A is more than 0. This is going to be positive. Opens up and negative. Opens down. Right, and that's going to flip the graph. Flip it. So flip right there when it's negative. Alright, this one is our h value right here. That's our left and right, and we change the sign. So if h is positive, that means we're going to move left. If h is negative, we're going to move right. And then our K, that's the one on the very end. This is going to be our up, down. Positive, move up. And negative, move down. All right. Okay, so then it says, the point where the two linear pieces intersect is known as the vertex. Using the variables above, the vertex can be found at what point? And we just talked about that. That's really easy. It's at HK. Now, we can look back at some of these and see if we can find the vertex real quick, because that's one of the assignments will just be find the vertex. All right, so this one, we don't have any numbers at HK, right? So the vertex of this one is just going to be 0, 0. And look, that's where it is, 0, 0, where it changes. See? Let's try the next one. This one, we've got that one written on there. So this one would be our h value. We don't have one, so that's going to be 0. And then our k value is right here, and that's going to be 3. 0, 3. And there it is. X is 0, y is 3. That's our vertex. All right, let's try this one over here. This one, we do have an h value, and that h value is 4, but that would be, we got to change it if it's inside of there, so that would be negative 4. And then we don't have a k value, so that's 0. Negative 4, 0 is our vertex, and there it is right there. Let's try another one. Let's try this one over here. So this one tells us our negative 2. We change that to a positive 2. We leave this one. That's our k value, which is negative 3. This has no bearing on your vertex. That's just how slopey your lines are going to be. So negative 2, 3, which means that we would go, no, positive 2, 3 means we would go over 2, down 3. That's right there. That's our vertex. Super easy to find. It's just HK. Just remember to change the value. This one would be negative 4, 2. Negative 4, 2, right there. All right. Let's see what else this has. Anything else? Describe the transformations to the parent function. This one, we're just going to move not left, but we change it so it would be, this is our left-right transformation. So we would move right 2. This one, this is our up-down. right, because that's our K value, right? This is our H value, horizontal. This one we're going to move up 3. Easy peasy. All right, this one's got a couple of translations. This one would be move, right here that tells us left 3. And then we want to, we would stretch by a factor of 2. Right. All right, so that's pretty easy. Write an equation for the absolute value function described. All right, so we want to flip this vertically. So we're going to have y equals, there's going to be a negative right there. And shift up 3 units. Up 3 units, that's going to be absolute value of x plus 3, right? Because our k has to go there. So this is going to be our up, down. And that's going to be our flip. Okay. All right, parent function squeezed vertically by a factor of 2. All right, so if we're going to squeeze it by 2, we're just going to go 2. Then our absolute value, shift it left, so that'll be x plus 3, because we have to change that sign, and down 4 units, minus 4. There's that one. So here's our squeeze right there. Left 2 is that, left 3 is that part, and then down 4 units would be this last part off in the end. Write an equation for these, so I could say, let's see, this is 1 over 1, so it's not going to have any squeezes or shrinks. Say y equals absolute value of x. Okay, so my horizontal, it shifted over 1, 2. Right, so I'm going to say minus 2 because I got to do the opposite. And then it's up 1, 2, so I'm going to do plus 2. All right, this one, its vertex is at 0, 0, but it has a slope of 2 over 1. So that would be y equals 2 times the absolute value of x. Right, because all we did was change our slope for both of those lines. All right, this one, we're flipping that upside down. So we're going to have a negative outside that. And this is a lot wider. So we're going down 1 over 2. All right, so our rise is 1 and our run is 2. Okay, now where do we move this? Our left, right, we went over 1, 2, 3. So x plus 3, remember, if we're going this way, it's going to be a positive on the x value. And then down 1, so that would be minus 1. So that's how you would write the equation for that one. All right, that's it for this lesson. Thanks for watching.